Okay. Hey guys, so this is a k nearest neighbors algorithm. So now we're going to talk about the k nearest neighbors algorithm. I actually have a small ugly data set on the right hand side, and then this is my XY plane. We're basically looking at the size of polar bears. So females versus males. You have the data point number, so we have 5 data points, and then the second column is a label: male, female, male, female, male. Again, it doesn't have to be in any particular order. And then this is your weight, excuse me, this is your height, and then this is your weight in pounds and inches. So we have this, we're gonna plot this out a little bit. So let's do the male, 95, 675. So that's roughly 675. If this was halfway, if this was 650, excuse me, if this was 650, right? And then this is halfway between them, so that's 84. Okay, so 95 and 675, that's pretty much out here. And so this is all the blue guys, so we'll just say that's him. And then the second male, 87 and 690, so he's further up here, but he's a little bit lower. And then the third male, he's 93 and 680. So that's a little bit in between. And then 93, that's, I'd say, roughly about here. Okay. Then we look at the females. We have 73 and 600. So 73 is right on the bottom. And then 600 is actually, excuse me, right here. So we'll actually make that a red color. And then you have the last female, 76 and 625. So that's 625, 76 might be around here. Okay, I have a very small data set here. Let's actually just pretend that we had like 1,000 data points. And so, let's make some more data on the fly. Okay, now the scenario here is we have polar bears, and essentially we want to be able to track. We have sensors that we can send out, essentially drones in the wild. They can take measurements of these polar bears. Don't ask me how, but they can basically calculate the height and the weight of a particular polar bear and determine whether or not it's a female or a male. Now, why is this a problem? Because polar bears, they're on the verge of extinction. So if we can classify it as a male or a female particular polar bear, we can then, if it's a male, if that male, if there are more females in the population, it's better to be able to classify a male out in the wild, and then we can bring that male in to encourage breeding. So this is a very, hypothetical scenario, but it could be real, but the idea is that we're trying to show how machine learning can really help solve problems here. So we're just going to put some more data. You'll notice you might have some outliers for the blues, and then you might actually have some reds here. So it's not perfectly overlapping, sure. But now the question here is, if I have a new data point, so this was our training data, and we've plotted our training data. Let's just say I had another data point, and the data point was this. It's a black data point because we don't know if it's a blue or red, and I want to know what it is, right? How do I determine that? I could say it's a female, or I could say it's a male, and then I would have to kind of justify why, right? Now, naturally, as human beings, we can see that this is closer to the blue dots. There are a lot of blue dots near it. So without even getting any formal definition of what a neighborhood is or anything like that, you just kind of know that this is going to be a blue dot. And that's the whole point behind k nearest neighbors. You basically choose a k value. So if I were to choose a k value of, I don't know, 5, you take your new data point and you find the 5 nearest neighbors. And that's why it's called k nearest neighbors. And so when you find the 5 nearest neighbors, After that, you just take a count. You tally up the votes. And if they're more blue, then you're going to call it a blue dot. And if they're more red, you're going to call it a red dot. It's just that simple. There are variants of k-nearest neighbors. This is just a hard yes or a hard no. And so basically in this scenario, it looks like this, this, and this. So these four dots are the closest. The fifth most, it's not this one. It's actually looks like it's that one. So they're all five of them are blue. So this is actually going to be a blue dot, and we can color it in. I'm just going to leave some black in there so we know. Now, if I was, for example, I don't know, choosing something like this, where I had another black dot here. So again, we're out in the wild. Our drone picks up and finds a polar bear. It takes the measurement, height, width, weight, and it calculates it, and it gets us here. And it needs to classify whether or not that particular polar bear is a male, so that they can bring him in and encourage breeding. Well, we look at this, if our k value is 5, then you have this is the closest, this is the closest, this is one, and this one, and it looks like this one might be the last one. So in this small little radius, if I were to draw this out, you'll notice that we have 4 votes for red and 1 vote for blue. So red wins. We would classify this as a female. And that's all k-nearest neighbor is. It's a classification algorithm, right? So it's for classifying. I hope I spelled that right. And it's a supervised algorithm. Supervised mean, again, we have the truth values when we're training, and which we did. This column right here is the truth values of male, female, or not. Or male or female. And so based off of that, we can actually generate a machine learning algorithm. So what we did here, real briefly, we first plotted our existing data, then we took a new data point, and then based off of that, we just set our k value essentially, and then we classified. So that's all k-nearest neighbors is, guys. We're actually in the next video going to talk more about how we implement this. This was just more for intuition. So thanks again, guys. See you in the next video.